Have you ever looked up at the night sky? Have you ever felt that sense of wonder? The stars seem to go on forever. It makes you feel quite small, doesn't it? For thousands of years we have stared into the darkness. We have asked the biggest questions imaginable. Are we alone in the universe? How did it all begin? These questions connect us to our ancestors. They connect us to the great thinkers of the past. But today we are asking a question that is perhaps even more profound. A question that challenges the very nature of everything we see. What if our universe is not the only one? What if new universes are being born all the time? This idea might sound like something from a science fiction film. It might seem like pure fantasy, a story told around a campfire. But this is not just a wild guess. It is a possibility that arises from our deepest understanding of reality. It comes from a field of science that is famously strange and wonderful. This field is called quantum mechanics. It governs the world of the very, very small. It describes the behavior of atoms and the particles within them. And it tells us that the universe at its most fundamental level does not play by the rules we are used to. The universe we experience every day seems solid and predictable. A dropped apple will always fall to the ground. The sun will always rise in the east. These are the laws of classical physics, the rules of our everyday world. Yet, when we zoom in, when we peer into the fabric of reality itself, this comfortable picture dissolves. It is replaced by a world of probability, uncertainty, and bizarre connections. A world where particles can be in many places at once. A world where observing something can change its state. This strange quantum world is not separate from ours, it is the foundation of it. So how do we get from the odd behavior of tiny particles to the grand notion of entire new universes? That is the journey we are about to embark on. We will explore how the puzzling rules of the quantum realm lead some of the world's brightest minds to a staggering conclusion. The conclusion is that reality might be branching. With every quantum event, a new timeline, a new world could be springing into existence. It is an idea that stretches the imagination to its absolute limits, but it is an idea grounded in real science, driven by equations and experiments that have been tested for a century. One of the most mind-bending ideas in quantum mechanics is something called wave-particle duality. Now, it sounds complicated, but honestly, the basic idea is quite simple. It means that the fundamental constituents of our universe, things like electrons and photons of light, can behave as both a particle and a wave. So imagine a tiny solid ball. That is a particle. Now imagine a ripple spreading across the surface of a pond. That is a wave. Quantum mechanics tells us that somehow a single electron is both of these things at the same time. How can this be? Well, it depends on how you look at it. The most famous example of this is the double-slit experiment. If you fire electrons one by one at a barrier with two slits in it, you might expect to see two simple bands on the detector screen behind. But that is not what happens. Instead, you see a complex pattern of many bands, an interference pattern, which is the hallmark of wave behavior. This means that each individual electron must somehow be passing through both slits at the same time. It is as if the electron, as a wave of possibility, interferes with itself before landing on the screen as a single particle. It explores all possible paths simultaneously. This wave is not a physical wave in water or air, it is a probability wave. The height of the wave at any given point tells you the likelihood of finding the particle there if you were to look. Before you look, the electron exists in this ghostly spread-out state of potential, a condition we call superposition. This concept of superposition is absolutely key. It is not just about location. A particle can be in a superposition of many different properties at once. It exists in a haze of all its potential realities. It is only when we interact with it, when we perform a measurement, that this wave of possibilities seems to collapse into one single definite outcome. Now we arrive at the very heart of the quantum mystery. It is a puzzle that has troubled physicists for a century. It is called the measurement problem. We have seen that before we look, a particle like an electron exists in a blurry state of superposition. But a strange thing happens the moment we try to observe the particle. The act of observation seems to have a profound effect on the system itself. The blurry wave of possibilities instantly solidifies into a single concrete reality. The electron suddenly has a definite position. it suddenly has a definite spin. It is no longer a ghost of potential. It becomes a real, tangible thing that we can point to. This is a profoundly strange and unsettling idea. In the classical world we are used to, observing something does not change it in such a fundamental way. When you look at a football rolling across a field, your act of looking does not determine its position. But in the quantum realm, the observer is not passive. The act of measurement is an active process that seems to force the universe to make a choice from its menu of possibilities. It is as if nature holds its breath until we look. This raises some enormous questions that venture into the realm of philosophy. What counts as an observation? Does it require a conscious human being? To highlight the sheer absurdity of this measurement problem, the Austrian physicist Erwin Schrödinger devised a famous thought experiment in 1935. It involves a cat, a box, and a bit of radioactive material. Imagine you place a cat inside a sealed steel box. Also in the box is a tiny amount of a radioactive substance. This substance is so small that in the space of 1 hour, there's an exact 50-50 chance that one of its atoms will decay. If an atom decays, it triggers a Geiger counter, which in turn releases a hammer that smashes a vial of poison, and the cat, unfortunately, dies. If the atom does not decay, the cat remains alive. Now, according to the rules of quantum mechanics, until we open the box and look, the radioactive atom is in a superposition. It has both decayed and not decayed at the same time, but because the fate of the cat is directly linked to the state of the atom, the cat itself must also be in a superposition. Faced with the profound puzzle of Schrödinger's cat and the collapse of the wave function, science needed a new way of thinking. In the late 1950s, a brilliant but then little-known physics graduate student at Princeton University named Hugh Everett III came up with a breathtakingly bold and elegant solution. He proposed an idea that would change the landscape of theoretical physics forever, an idea we now call the many worlds interpretation. Everett's proposal was simple but revolutionary. He asked a powerful question. What if the wave function never collapses at all? What if the strange superposition of states is not just a temporary mathematical trick that disappears when we look? What if it is the true, complete, and unvarnished description of reality? In this view, there is no special moment of collapse. The universe, according to Everett, just keeps on evolving, smoothly and deterministically, following one single, beautiful law. So, what does this mean for our poor cat in the box? When you open the box, the universe itself splits into two. In one branch of reality, you open the box and find a living cat. But in another, completely separate branch of reality, a copy of you opens an identical box and finds the cat has sadly died. This is the core of the many worlds interpretation. Every time a quantum event has more than one possible outcome, reality itself cleaves into multiple parallel streams. All possibilities are realized. None of them are wasted or erased. The many worlds interpretation gets rid of the awkward measurement problem by expanding our definition of reality. It proposes that there is only one fundamental entity in the cosmos, the wave function of the entire universe. This is often called the universal wave function. It's a single, colossal mathematical object that contains everything. It describes not just one particle or one cat, but you, me, the Earth, the Sun, and every single galaxy all at once. In this picture, we, as observers, are not separate from the quantum system we are measuring. We are part of it. When you measure the spin of an electron, you and your measuring device become entangled with it. This all sounds like the stuff of science fiction. If new universes are being created every single moment, why do we not feel it? Why does reality seem so solid and singular? The answer lies in a crucial quantum phenomenon called decoherence. This is the process by which the different branches of the universal wave function effectively become sealed off from one another, making it practically impossible for them to ever interact or communicate again. Think of it like two ripples spreading out on a pond. When they are close, they can interfere with each other, creating a complex pattern. But as they travel further and are disturbed by wind and other ripples, their connection is lost. They become two separate, independent waves. In the same way, once two branches of the universe have decohered, they go their separate ways. The alive cat branch and the dead cat branch can no longer interfere with each other. For all practical purposes, they are now completely separate, parallel worlds. The split is irreversible. This is why we only ever experience one outcome. Our consciousness is tied to the particles that make up our brain and body. As we become entangled with one outcome, we are carried along that specific branch. So while the universe may be splitting continuously, the process is so seamless and total that from within any given branch, it is completely unnoticeable. Reality appears classical and singular, hiding the vastly more complex and branching structure that may lie beneath. The many worlds interpretation offers one way that quantum mechanics might generate countless universes. But you know, it is not the only idea on the table. Another fascinating possibility comes from its marriage with cosmology. This idea is known as eternal inflation. It suggests that our universe is just one bubble in a vast cosmic ocean of other bubble universes. Each bubble is a self-contained cosmos, potentially with its own unique laws of physics, existing within a much larger entity called the multiverse. Eternal inflation theory suggests that this process, once started, might never completely stop everywhere. This expanding space, the multiverse, continues to spawn new bubbles, new universes, constantly and for all eternity. Another compelling, though speculative, idea is that universes are not just born, but are also reborn in an endless cycle of creation and destruction. This is known as the cyclic universe model. It draws on ideas from string theory. In this scenario, our Big Bang was not a unique one-off beginning, but rather the result of a collision between two pre-existing brains, vast, higher-dimensional objects floating in a larger space. Following the collision, the brains bounce apart and our universe expands and cools. Over countless eons, they slowly begin to move towards each other once again, triggering another Big Bang and starting the entire cosmic story over in a cycle that could potentially repeat forever. Perhaps the most reality-bending idea of all is the holographic principle. This concept suggests that all the information contained within our entire three-dimensional universe can be described by a theory that lives on a two-dimensional surface. It's kind of like a hologram, where a three-dimensional image is encoded onto a two-dimensional film. In this view, the universe we experience as three-dimensional might just be a projection, a holographic illusion generated from information stored on a distant cosmic surface. Taking this idea one step further leads us into even more philosophical territory. If our universe can be described by information like the code of a computer program, could it be that our reality is, in fact, a simulation? This is the simulation hypothesis. So these ideas, from the branching realities of many worlds to the cosmic foam of eternal inflation, force us to fundamentally reconsider our place in the grand scheme of things. For most of human history, we've placed ourselves right at the center of creation. But these quantum theories challenge that last bastion of cosmic importance. They suggest we might be anything but special. If the many worlds interpretation is correct, our entire life story is just one path taken among an infinite number of others. We're not the trunk. We're not even a main branch. We're just a single tiny twig. Similarly, the idea of eternal inflation paints a picture of our universe as just one bubble in an endless, bubbling cosmic ocean. These theories about new universes do something remarkable. They blur the traditional lines that have long separated the domains of science and philosophy. For centuries, questions about the nature of reality were the preserve of philosophers and theologians. But theories like the many worlds interpretation change this dynamic completely. They arise directly from the mathematical formalism of our best-tested scientific theory. It takes the equations of quantum mechanics and follows their logic to its ultimate conclusion. This convergence forces both scientists and philosophers to engage with each other's ideas in new ways. It is a modern continuation of the oldest human tradition, trying to make sense of the cosmos. While we may not yet have definitive proof that other universes exist, the very possibility of them acts as a powerful engine for scientific and cultural progress. These mind-stretching ideas inspire new generations of scientists, thinkers, and artists. The quest to understand these fundamental questions pushes our technology to its absolute limits. This drive for discovery leads to technological innovations that often have practical benefits for society. Furthermore, these ideas have a profound impact on our collective culture. They have seeped into our stories, our films, our art, and our everyday conversations, acting as modern myths that help us navigate a universe far stranger than our ancestors could have dreamed. So, where does this leave us? We stand at a remarkable point in our history. We have a physical theory, quantum mechanics, that works with unparalleled precision. It has given us the modern world of computers and lasers. Yet it presents us with a vision of reality that is deeply puzzling. The existence of other universes is one of the most profound implications of taking that theory seriously. It forces us to confront our own cosmic significance, or perhaps our lack of it. It is a humbling perspective, but also an incredibly exciting one. The quest to find answers continues. Physicists around the world are designing new experiments. They are searching for clues in the faint light from the Big Bang. They are smashing particles together in giant accelerators. It is a slow and difficult process. The answers, if they come, will not come easily. But the search itself is a testament to the insatiable curiosity that drives the human spirit. The universe is under no obligation to make sense to us, but we will keep trying to make sense of it. We will keep exploring, questioning, and imagining, because to be human is to wonder. For millennia we have looked to the heavens and wondered. Today we are still wondering, but our questions have become sharper, and our tools have become more powerful. The possibility that new universes are being born is perhaps the grandest question we have ever dared to ask. It fills us with a sense of awe. It reminds us that no matter how much we learn, there will always be new mysteries waiting to be uncovered. The journey is far from over. This is not the end of the story. In many ways, it feels like we are still at the very beginning. And in a cosmos of seemingly infinite possibilities, the potential for discovery is truly endless. The adventure has just begun. Thank you for joining me on this exploration of one of the most profound ideas in all of science. They have shown us that the reality described by our best theories is far more mysterious and magnificent than the solid, simple world we perceive with our everyday senses.